All right, this Venn diagram problem is for my non-honors geometry. Honors geometry can also learn something from this, I suppose, as well. So there are 60 students total. 25 students attend woodshop class, 20 students attend computer class, while 22 students don't attend either class. Draw a Venn diagram to show the situation. We're going to let W stand for the students who attend the workshop. We're going to have C stand for the woodshop, and C is the computer class. So we have two circles, W and C. And we know there are 60 students total. And we know that 22 don't attend either. So they're not in either of these circles. There's us something outside. 60 minus 22 equal what these two circles add up to. So that's 38. So what that is actually saying is that let's not do probability. Let's talk about it as W plus C minus, or they're together, and that's 38. Because we don't know where they intersect. Well, there's 25 wood choppers, 20 computer class, minus 38. 45. So we subtract 45 from both sides, and we get x equals 7, and that's where they overlap. So 7 is the overlap. Now to get the rest of the wood shop, well, we know there are 25 total, so 25 minus 7 is 18. And we know there are 20 in the computer class, minus a 7 that's in both, so we have 13. And we can add all four of those numbers up, make sure they're equal to 60. 22 plus 18 is 40, plus 7 is 47, plus 13 is 60. Now we can do some probability based on those problems. And I want my answers in fractions, not decimal. Simplified fractions. So the probability that they're in wood shop is everything in that circle. So 18 and the 7, so 25 out of 60, that's the total number of students, which of course we can reduce down to 5 over 12. If we do the same thing for C, the probability that they're in computer class, it would be 20, because there's 20 in the C circle, 7 and 13, over 60, which is 1/3. Now, we're looking at this U. The U is a union, and it means 4. So it's W plus C minus W and C. Or we can just add up either one. So we have 18 plus 7 plus 13 is 38. Well, we can see what we did up here. 25 plus 20 is 45, minus the 7 gives us the 38 that we want here. So that was already told to us, really. Now, the upside down union, the intersection is our and. So where they overlap, just the 7 out of 60. Oops, and this would be over 60, 19 over 30. Now, looking at our conditional probability. Probability of W given that C. So we're looking at our C circle. So it's out of 20. We're using our formulas. That's our C. Well, out of C, how many are W's? Well, 7. 7 out of that is also in the W circle, and that's simplified. If we're looking at the other way around, we're looking at our W circle first. So out of 25. And how many are at C? Probability of C, well, there's 7 in there. So the numerator's the same, but the denominator's change, just like we saw with the two-way table. Complement, pretty straightforward. 1 minus probability of W, 1 minus 5 over 12, 7 over 12. We can do the same thing with probability of complement of C, minus probability of C, which is 1 minus 1/3, 2/3. Pretty straightforward, not a whole lot of stuff going on with the complements. All right, this is for the honors geometry. We have 3 things going on here, so our Venn diagram is going to get kind of crazy. A nutritionist at school is planning a scheduled breakfast for 175 students. All students picked at least one option. 73 students say they want milk. 97 want juice, and 60 want fruit. So we have our, down here, we know that total M is 73. Total J is 97, and total F is 60. Obviously, there's an overlap because that adds up to over 175. 19 said they want both milk and fruit, but 11 want juice as well. So these 11 are included in that 19. So we got to look at that. And that's probably where we're going to start. 34, only milk. 36, fruit only. So that'll help us. So there is intersection because we have the 3 together. So we got 1, 2, 3 circles. We have milk, juice, and fruit. Now we know that 19 want both milk and fruit. Well, you know 11 want juice as well. So 11 want all 3, so where they overlap is right there. So where all 3 circles overlap. Now the rest of the overlap between milk and fruit in this section here has to add up to 19, so we have 8 here. We also know that 34 only want milk. So that'll be the rest of the circle that's not overlapped. So to get this part, we can do how many people want milk. So 73 minus 34 minus 8 minus 11 will give us this overlap, which is 20. We know that 36 people want fruit only. So 36 is here. And again, we know that fruit, there's 60 students who want fruit. Subtract 36 minus the 8 minus 11 that overlap will give us that last section, which gives us 5. And then for the same thing, we know that 97 want juice, so 97 minus 20 minus 11 minus 5 will give us how many people like juice, just want juice, and that's 61, and that's not too bad. So it's just subtraction. Now we want to use that to do some of these problems. Probability they like milk, so it's everybody in the milk circle. So all 4 of those things added up, which we already know is 73. Out of our 175. Juice, again, we know is 97 out of 175. And fruit, again, we already know is 60 out of 175. Those were told to us. We don't have to think too much. We do need to simplify that down to 12 over 35. The complements are just the opposites. 175 minus 73 gives us 102 over 175. Complement of juice is 175 minus 97, which is 78 over 175. And the complement of fruit is 175 minus 60, or 115 over 115, or 175, or 35 minus 12, because we want the simplified version anyways. So we found those just because they have to add up to 1. Now, remember that that symbol means intersection with our and. So our and for M and J is this section here. So it's 31 out of 175. Intersection of J and F, let me get a different color here so we can see the difference. The intersection of J and F is here. So 16 out of 175. See if I can move down a little bit and still get our problems. The intersection of M and F is here, and we already knew that. That's what was given to us. So it's 19 out of 175. The intersection of all 3, or where they all intersect, would be that little section in the middle here. Which again, we already knew from this. So 11 out of 175. Now our union symbol means and. The U means and. So we want to add them up, but subtract off where we have left over. Or we can just add up the numbers. So M and J, so we want to add up, try and get a different color here, all of M and J. So this, and this. Everything in M and J. So really, it's 175 minus the 36, because everything's in one of those circles. So 175 minus 36 is 139 over 175. And we're going to do the same method for J and F. So it's everything except for that. So 175 minus 34 is 141. So as I was saying, we're going to just finish up. The probability of M and F is all of the other ones, except for J here. So 175 minus all of those, which is 115, or 114 out of 175. Sorry, that was 119 out of 175. And then the union of all three of them was all three of those added up. That's everybody. So it's 175 out of 175, grand total of 1. Now our conditional probability, where it gets iffy. The probability of M given F. So now we're looking at the F circle. And that's, so it's, remember that the probability of A given B, the probability of A and B, over the probability of B. And really, I guess we're looking at numbers. So what's the probability? So what is it out of? It's out of F. Well, F we already know is 73. And the ones that are M as well are the 19. Vice versa, we're out of M. That's our denominator. So we know M is true. M is 73. And the combination is 19. I did that last one backwards. It should not be 19 out of 73. Out of F, F was 60. So I got those backwards. I apologize. So moving on. Again, it's out of all the J's, because we know J is given. J is 97. And the probability that's in M and J is this intersection here, 11 and 5. So 16. M and J is not 16. Having some trouble here. M and J. Get my pen back. M and J is here, 20 and 11, so 31. Now here, M and J is still 31, so the numerator doesn't change, but now the denominator does. It's out of M. Our M is 73. The numerators are the same, the denominator is different, just like 16 and 17. We're going to do the same thing for these last two. The numerators are going to be the same. The probability of F and J. Well, F and J are the 16. But here we know it's out of J. Our second thing has happened. So J is 97. And here the second thing has happened, F. So it's out of F, which we know is 60. And of course, we can simplify that to 4 out of 15. So are M, J, and F disjoint? No, because the probability of M and J and F is this 11 out of 175, which is not equal to 0.